A long time ago, in a country far away, somebody needed to solve that equation. X squared plus 1 equals 0. Looks like a pretty simple equation, doesn't it? How would you solve that equation? Subtract 1 on both sides. Okay, we're going to use our square root method. So we subtract 1 on both sides. X squared equals negative 1. And then what do? Square root both sides. Square root of x squared equals plus and minus square root of negative 1. So x is plus and minus square root of negative 1. And therein lies the problem. What's the square root of negative 1? Can't do it, can you? Why not?
Can't have any negatives in the square.
Why not? Well, a lot of people will try to tell me that the square root of negative 1 is negative 1. But the square root of negative 1 is not negative 1. Why not? Negative 1 times negative 1 is positive 1. So what's the square root of negative 1? 1. Nope, because 1 times 1 doesn't give me negative 1 either. All right, so the problem is there is no real number solution to this equation. There's no real number that works. So what do you do when there's no real number? Nope. It's kind of like when you were a little kid and you didn't have any real friends. What'd you do when you didn't have any real friends? You made up imaginary friends. What do we do when we don't have any real numbers? We make up imaginary numbers. So we define I to be the square root of negative 1. And we use I for imaginary. I stands for imaginary. All right, so that's going to allow us to write down answers for equations that we couldn't solve before. For example, let's say I gave you, here's another one that works kind of the same way. X squared plus 4 equals 0. How would you solve that equation? Same way. Subtract 4. X squared equals negative 4. Then you do square roots. So x is plus and minus. What's the square root of negative 4? It's an imaginary number. Which imaginary number? Not 4i. Not I. 2i. Why 2i? The square root of 4 would be the number 2. And the square root of negative 1 is I. So we think of this as being, we think of negative 4 as being 4 times negative 1. The square root of 4 happens to be a nice number. Square root of 4 is 2. And then the square root of I is negative 1. So we would write, our square root of negative 1 is I. I said that backward, didn't I? So we would write x equals plus and minus 2i. Questions on that? All right, now the answers might be a little bit more complicated than that. Let's say we had 3 times 2x plus 1 squared plus 75 equals 0. How would you solve that equation? Minus the 75. So what are you doing first? And what's your kind of your goal here for this equation? You want to get to the point where you can square root. So in order to do that, you need to get this parenthesis thing alone. Next step then is to divide by 3. So 2x plus 1 squared is minus 25. 75 divided by 3 is 25. Now we're ready to square root. So 2x plus 1 squared square root is plus and minus square root of negative 25. On the left-hand side, the square and the square root, those always cancel each other out. They're inverses. How about on the right-hand side? What's the square root of negative 25? 5i. Square root of 25 is 5, but anytime you have a negative underneath your square root, what are you going to write? You're going to write an I. Anytime you have a negative under a square root, you're going to write an I. So that would be plus and minus 5i. Still a couple steps left to go. What are the couple steps left to do now? Subtract 1, and then finally divide by 2. So 2x equals negative 1 plus and minus 5i. So final answer looks like x equals negative 1 plus minus 5i over 2. So you're going to see some problems like that in section 7.3. You're going to see some problems where you go to solve using the square root method and you get negative numbers underneath your square root. If you get negative numbers underneath your square root, that's okay. You're just going to write them using I. Section 11.3, we're going to talk a little bit more about numbers with I in them. So section 11.3, complex numbers. A complex number is any number that can be written as a plus bi, where a and b are real numbers. So let me give you some examples of some complex numbers. Examples. 5 plus 2i. 5 plus 2i is a complex number. How come? It's got an I in it, and a and b are real numbers. 5 and 2 are real numbers. How about this one? 1/2 minus 2/5 I. Am I allowed to use fractions? Yeah, a and b can be real numbers, which means I can use fractions. It says I'm supposed to have plus bi. How come I can have minus 2/5? How come that's okay? It's the same as having plus a negative 2/5. That's correct. 7. Is 7 a complex number? No? You sure? How about if I were to take the number 7 and write it as 7 plus 0i? Can I write 7 as 7 plus 0i? Yes, I can. So is 7 a complex number? Yes, it is. More importantly, 7 is a real number, but 7 is also a complex number.
How did you get the half? You just plus it.
Oh, I'm just making up numbers here. The half is just a number I made up off the top of my head. It didn't come from anywhere special. I just wanted to point out that you can use fractions if you want. How about my last complex number? 4i. Is 4i a complex number? Yes. Where's the a? It's 0. Again, I can write 0 plus 4i. So it turns out that any number you can think of is a complex number. All numbers are complex numbers. Some of them are real, and the real ones are, of course, a lot more important. Like 7 happens to be a real number, but it also happens to be a complex number. It can be both. So what you're going to be asked to do in this section, you're going to be asked to add, subtract, multiply, divide, and do powers on complex numbers. So let's start with adding first. How would I take 5 plus the square root of negative 4 and add 6 minus the square root of negative 16? What do you think you should do first?
Square root of 2i.
Correct. You should get rid of the square roots and write them using i's. Perfect. So you would write this as 5 plus 2i plus 6 minus 4i. And then how do you add complex numbers?
Combine and just do FOIL or distribute?
No FOIL because we're adding.
Just distribute.
You just add them like they were x's. Add like terms. What's 5 plus 6? 11. What's 2i minus 4i? Minus 2i. That's it. So if you're adding, it's just like there was an x there, you add like terms. Would subtracting be any different? Not really. The only thing you'd have to be careful of with subtracting is your signs. 3 minus 5i minus 1 minus 6i. What's the only thing you need to be careful of? Distribute the minus sign through to change all your signs. So I would write 3 minus 5i minus 1 plus 6i. And that's the most single common mistake right there. People will write negative 1 minus 6i. They'll forget to distribute the minus sign through. That's all. Combine your like terms. 2 plus I. 2 plus I. Okay, how do we multiply complex numbers? If I were to give you 3 plus 4i and asked you to multiply by 2 minus I, what would you do? Distribute. So this is just FOIL, isn't it? To multiply two complex numbers, you just do FOIL. And we like FOIL. Why do we like FOIL? Because it's easy. That's right. We like FOIL a lot. It's nice and easy. All right, so we FOIL. We write 6 minus 3i plus 8i minus 4i squared. And then what would you do? Ah, very good. I squared, you can get rid of I squared. Remember what we said I is? What was I again? I is imaginary, but in particular, I is square root of negative 1. So how much is I squared? If I were to square both sides, what happens to the square root and the square? They're inverses, they reduce each other. So I squared here, I squared is a fancy way of writing the number negative 1. So what we would do, we would write this as 6 plus 5i plus 4. Because I squared is the number negative 1. And then I can combine my like terms. All right, my final answer is 10 plus 5i. So multiplying complex numbers is pretty easy. You do FOIL like you've always done. The only change is you're always going to have an I squared, and you're always going to replace I squared with a number negative 1. Whenever you see it.
So it's just going to basically change from a positive or a negative?
That's correct. If it's negative, it's going to change it to a positive. If it's positive already, it would change it to a negative. All the I squared is going to do is change the sign. That's absolutely correct. Okay. Well, that was good. I liked multiplying. That was easy. How about dividing complex numbers? I don't know. 5 minus I over 3 plus 2i. Anybody know how to divide complex numbers?
Subtract.
Do what? Well, not really, because that only works when things on top and bottom are connected with multiplication. Because multiply and divide come in the same place in the order of operation. Unfortunately, we've got a minus and a plus here. That doesn't work. What we do is we multiply top and bottom by something. And the something is called the conjugate. Anybody know what conjugate means? Conjugate is a fancy word for change the number in the middle. So instead of 3 plus 2i, I'm going to multiply by 3 minus 2i. Conjugate just means change that sign. Why does that help? Well, let's see what happens. Let's do the bottom first. To multiply those, I would just go ahead and do FOIL, wouldn't I? So if I do FOIL, I'm going to get 9 minus 6i plus 6i minus 4i squared. I'm going to FOIL the top and the bottom, but I'm just going to concentrate on the bottom first and show you why we used the conjugate. It's just 9 plus 4. 9 plus 4. Notice that the middle two terms cancel out, and that's why we use the conjugate. We change the sign in the middle. When you change the sign in the middle two terms will cancel out. And then why is this just 9 plus 4? I squared becomes -1, just like it did when we did FOIL a minute ago. So what happens is, multiplying by the conjugate makes the i's on the bottom go away. And that's kind of the goal there. The goal is to make the i's on the bottom go away. Okay, so now I got to FOIL on top and just see what I get. When I FOIL on top, I get 15 minus 10i minus 3i plus 2i squared. So that's going to be, again, this 2i squared is going to really be what number? -2? Oh, I'm sorry, the 2i squared. The whole thing will be, the I squared will be -1, but the 2 will make it a -2. So we've got a 15 and a -2. 15 and -2 makes 13 minus 13i. Right. If I multiply the bottom by 3 minus 2i, then I have to multiply the top by exactly the same thing. Basically, I multiplied by the number 1, didn't I? Anything divided by itself is the number 1.
So if it began as a negative, you change the top.
Right. If this had started as a negative here, I would change it to a positive there. Absolutely. Now, on this problem, we get very, very, very lucky. And it really, truly was lucky because I just made up these numbers at random. This isn't usually going to happen. But notice we've got a 13 here, a 13 there, and a 13 there. What can we do? We can reduce everything by 13, so we end up with 1 minus I. That's not normally going to happen. Normally your answer is going to end up being some sort of fraction. We just got lucky on that one. All right, the last thing I want to show you. I have very good news for you. Oh, that wouldn't be good news, would it? A take-home quiz would be good news? No. The good news is, on your calculator, you might notice on the button that has decimal point, there's a little I right there. So on your calculator, if you wanted to do 5 minus I divided by 3 plus 2i, you can type it in. 5 minus I divided by 3 plus 2i. Got to use the parentheses. That's the big thing people will forget. Use the parentheses, hit enter. And in this case, the answer turns out to be very nice because we didn't end up with a fraction. Normally, when you divide complex numbers, you're going to get some sort of decimal things. What would you do if you got some sort of decimal thing? Hit math, enter, enter, and turn it into a fraction. Okay? Let me just make up a different one. What if I did 6 plus 2i there? See how it gives me decimals? I would just go math, enter, enter, and it will turn them into fractions for me. Okay? So everything we did in this section, you can do it on your calculator.